Our project title is that AI power supply chain optimizer. In the today's world, the supply chain are very critical and facing a lot of inefficiency. So the large scale enterprise company like Amazon, Walmart and FedEx are using AI to optimize their supply chain. They are using an advanced solution and having expertized data scientists. It is typically very expensive and very complex, and it is not accessible for the small scale business. In this project, we are going to create an AI-powered system that uses machine learning for analyzing a supply chain risk. Over to our problem statement. The global market is facing an inconsistency in supply chain due to the dynamic conditions. It can be overstocking, stockouts, or delivery delays. It can lead to reducing customer satisfaction and inaccurate demand forecasting. To overcome this issue, our project proposes an AI-powered system that analyzes real-time and historical supply chain data to make the better decision making. So this system is particularly focusing on small and medium-sized business. We can take the supermarket for an example. The supermarket will not have the data scientists or high-level technologies to maintain their supply chain. But our project is very affordable, so it will give the perfect solution for it. Because we have designed this system in such a way that even a people without a high knowledge in the technologies, which means a non-technical user can also use and understand it. So this is the output of our project. By clicking this browse file, we can upload the data set here. But I have already uploaded one dataset, so let's skip this step. And let me explain the technical stack of this project. The first one is demand forecasting using Prophet tool. The Prophet is nothing but a forecasting tool that is used to predict the future values. We specifically used this tool for predicting the future sales. This Prophet tool expects the data in two columns, which is DS and Y. DS for the date and Y for the number of products sold. Here we can also change the column name, but currently we are in the need of these two columns, so I have selected this. Forecasting. The forecasted demand is visualized in three ways. The first one is sales trend chart. Here in x-axis we have the date and y-axis we have the units sold, which means a number of products sold. And this is a sales trend chart, and it shows the overall sales movement over a time. And second one is bar chart. Here in x-axis we have the product type, and in y-axis we have the total units sold. And here the sales are compared across the different products. And the third one is the forecasted trend chart. Here it provides future demand prediction between the specific intervals. We can also adjust the forecasted days by adjusting it in the sidebar filters. I give you the 25 days, and this orange line will be extended for the 25 days. See, you can see this in an orange line. So this is how the demand forecasting works. And our next main feature is that sales prop alert system. So we have given the certain KPI metrics here, which is today's sales, yesterday's sales, total sales, average daily sales, and best day of sales here. So whenever the user set the date range, the dashboard updates accordingly. The main agenda should be today's sales must be greater than yesterday's sales and average daily sales of 7 days. If today's sales is less than yesterday's sales, it should be considered as the normal variation. But if today's sales is less than the average daily sales of 7 days, the system will rise and sales drop alert. So let me explain this clearly. Here you can see that today's sales is greater than both yesterday's sales and average daily sales, which means a sales is going perfectly. The alert will not be triggered, and you can also see the message like no significant sales drop versus 7 days average, which means everything is going perfectly, and this is a positive case. And coming to the next image, here you can see that today's sales is less than yesterday's sales but not average daily sales. So this is also not a big deal. So the alert will not be triggered, but you can see the small red down arrow indicating that today's sales is less than yesterday's sales, but the alert will not be triggered. Just we can be alerted like today's sales is less than the yesterday's sales. In case today's sales become less than yesterday's sales and average daily sales, then you can see a message like this: sales drop detected, and it will trigger an alert and send a message to your email, Telegram and WhatsApp. And you can also see a message like this. So this is how sales drop alert system work. And our next important feature is route optimization. Here we implemented a route optimization to minimize delivery distance and improve logistic efficiency. The system takes the warehouse location as a starting point and multiple delivery location as an input. Here you can see the warehouse X coordinates and Y coordinates. So it should be always be in 0, where we consider 0, 0 in a graph. So this is warehouse. So consider this as one supermarket. And this number of delivery location is how many location, which means consider it as the customer house. So how many delivery location we are going to select. So currently I have given a 3 and we can also give it as a 4. Now it will change to the location 4x, location 4y. So we can get the 4 locations here. So let's give some coordinates here. So I have given randomly. It calculated distance between the point using a Euclidean distance formula and evaluate all the possible routes using permutation based approach to find the optimal path with minimum total distance. The output shows the best route ordered. By clicking this optimize route, we can get optimize best solution. So here it found the best route found, and this is the best route to deliver to the different customers, and this reduces the travel cost and delivery time. In the real world application, this approach can be extended using map based APIs like OpenRoute service or a Google Map to consider actual road condition and a traffic. And our next core feature is reinforcement learning. We implemented a reinforcement learning based inventory optimizer to enable intelligent and adaptive stock management. We model the system as the custom environment where the agent interact with the historical data such as stock levels, sales demand and lead time that you can see here. And in the sidebar filters, we have given a oral settings for training episode, episode length and also a state. Here the training episode means this is all about how well the system works and will be trained. If it is set to 0, the output will be poor. And if it is 1000, it will be more efficient, which means it is trained more effectively. And the episode length can also be adjusted. Now currently the one episode will be considered as the 30 days. If I change here, the one episode will be considered as the 40 days. So this is how these filters will work. And the state is, now I have given a 5. So the state will be very low, low, medium, high and very high. So according to that we can adjust it. We can also give it as 3. If I give 3 means it will consider it as low, medium and high. In the first graph, we can see the blue lines here. This blue lines indicates the reward of the agent while training. And here we can see the another graph. So it is stockouts per episode. So how the agent reacts when it faces the stockouts. This is what it is meaning. And this is stock levels and actions, what action to perform during this stock level and demand level. And the final solution will be like this. Reorder, we need to reorder 705 units. And this is how our project works. Thank you.